This is section 7.1, part 2. We left off with fifth operation. We hadn't talked about it yet. The first four operations, adding, subtracting, multiplying, and dividing, that's something you would have done before in Algebra 1. Fifth operation is called function composition. Now this should be new. The notation for function composition is kind of weird. I can either say f of g of 2. Notice my g of 2 is actually inside the parentheses for my f function. Another way of writing exactly the same thing is f and then this little open circle. Now be careful because this is not a closed circle. It is not times. It does not mean multiply. It is function composition. It's a new symbol. You would not have seen it before. And you would read this as f composed with g of 2. F composed with g. So let's talk about how you do function composition. And again, it's going to sound kind of crazy because you actually start with the second function. So what we're going to do is we're going to take this 2, this is our x value, we're going to plug it into our g function first. So the first thing we need to find is g of 2. So we take 2 and replace our x value. So any x value we have, we're going to replace it with 2. And we're going to simplify. 2 times 2 is 4, plus 1 is 5. So we would say g of 2 is equal to 5. Now here's the weird part. When we find f composed with g of 2, we don't take 2 and plug it into f. We do not take 2 and plug it into f. We take the answer to the g of 2. That's the number we plug into our f function. So for our f function, we want to find f of 5. So we want to find f of 5. So we're going to take 5 and plug it into our f function. So we have 2, and we're going to replace the x value with 5. So 5, and that is squared, minus 3 times 5. So anywhere there's an x, you're going to replace it with 5. Now remember, with order of operations, we do exponents first, or after parentheses, but these are multiplication parentheses, not grouping parentheses. So we're going to square the 5, which is 25. And after exponents, we have multiplication. 2 times 25 is 50. 3 times 5 is 15. And we get 35. So f should be f, not g. F composed with g of 2 is equal to 35. Let's do another example. Notice I have g composed with f. Notice my f function comes second. So you're going to plug that -1 into the f function first. So first thing I need to do is find f of -1. Remember, when you substitute in, you have to put it in parentheses. So f of -1, -2 times -1 is 2, plus 6. F of -1 is equal to 8. The 8 is the number that we're going to plug into our g function. So we need to find g of 8. Anywhere there's an x in the g function, we're going to replace it with 8, plus 3. 4 times 8 is 32. Add 3. And coincidentally, we get 35 again. Notice now I do not have a number. So you do this in a similar way, kind of. So you still start with your g function. And whatever you get for your g function, you're going to plug it into your f function. So we're going to start with our g function, which is g of x, 3x minus 7. Since we don't have a number to plug in, this is going to be our g function. That's what we have to plug into the f function. So our f of g of x, we have to take this 3x minus 7 and substitute that in for x. So I've got my negative 6 for my f function, but instead of x, I'm going to replace it with my g function. It does need to go in parentheses. 3x minus 7. And I still have the plus 5. I'm going to simplify that by distributing the negative 6. Negative 6 times 3x is negative 18x. Negative 6 times negative 7 would be a positive 42 plus 5. And 42 plus 5 is 47. So f composed with g of x. We could also write f of g of x. Two different notations for the same thing. Negative 18x plus 47. Be careful here. You got to see which one is on the inside. So the f function is inside. We're going to start with the f function then. So we have f of x is equal to 3x plus 2. And this is the function that has to get substituted into our g function. So we need g of f of x. I still have my 9 for my g function, but instead of x, I'm going to replace it with my f function, 3x plus 2. Don't forget the parentheses, plus 4. And simplify. 9 times 3x is 27x. 9 times 2 is 18. And 18 plus 4 is 22. Example 15, I'm going to have you try and work that one yourself. And this is a sample question from the school district exam. Notice they used different notation than I did. This says f of x minus g of x. So I need to take my f function first, which is 2x squared. Has to go in parentheses. I need to subtract my g function in parentheses, minus 3x plus 2. Remember there's a little negative 1 out front that does have to be distributed. So you have 2x squared. Negative 1 times x squared is negative x squared. Remember to distribute. The negative 1 times the negative 3 is positive 3x. And times the 2 is negative 2. Combine like terms, 2x squared minus x squared plus 3x minus 2. Correct answer then would be B. Product. Product means multiply. We want f of 4, and we need to figure out what that is. We need g of negative 1, have to figure out what that is. Then we want the product of those two answers. First thing we need is f of 4. So we have 3 times 4 minus 1. So f of 4 is equal to 12 minus 1, or 11. Then it's asking for g of negative 1. So I got to do that next. Replace my x with negative 1. And simplify. Negative 2 minus 3 is equal to negative 5. And remember, I want the product of f of 4, which is 11, and g of negative 1, which is negative 5. So 11, product means multiply, will give me negative 55. Answer A. One more, we have f of g of x. Notice g is the inside function. So we're going to start with our g function, which is x squared minus 3x. We're going to take whatever this is, and we're going to substitute it in for x in our f function. So we're going to replace our x with x squared minus 3x. And we still have the plus 2. And if we simplify, x squared minus 3x plus 2. Answer A.